On this question, I want to find the equation of the tangent line at the point x equals 3 for this function f of x equals square root x plus 1. Now when we're finding the equation of a line, we're going to use the point slope form. That's y minus y1 equals m times x minus x1. And we've already got the x value, x equals 3, which is the value that we would substitute in for x1. We need to also get y1, and y1 we get from calculating f of 3. We're going to get that by calculating f of 3. That's the y value when x is 3. And we also need to calculate the slope of the tangent line. And we can get the slope of the tangent line by calculating the derivative at x equals 3. So we need the derivative of f, and we need to evaluate it at the point x equals 3. So we need to do a couple calculations first, and then we'll be able to find the equation of the tangent line. So let's calculate f of 3. F of 3 would be square root of 3 plus 1, which is square root of 4, and that's 2. And then I need to calculate the derivative to find the slope. So to calculate the derivative, I would first use algebra to rewrite this as x plus 1 to the 1/2 power. And then to calculate the derivative, I'll use the chain rule. I'll bring the power down, leave the inside alone, take 1 away from the power, and chain by multiplying by the derivative of the inside. So this would be 1/2 times x plus 1 to the negative 1/2. And the derivative of x plus 1 is 1. So if we simplify this, it would be 1 over 2 square root of x plus 1. So I found the derivative, and now I need to find the slope of the tangent line at x equals 3 by substituting a 3 into that derivative. So that would be 1 over 2 times the square root of 3 plus 1. That's 1 over 2 times the square root of 4, and that's 1 over 2 times 2, which is 1/4. So now we have the slope of the tangent line being 1/4. And now I'll use my point slope form to find the equation of the line. That's y minus 2 equals 1/4 times x minus 3. That's y minus 2 equals 1/4 x minus 3/4. And I can add 2 to both sides to get y equals 1/4 x. And I'll need to change 2 to a fraction. 2 over 1, I'm going to multiply by 4 over 4 to get 8 over 4. I've got negative 3/4 plus 8/4, and that's y equals 1/4 x plus 5/4. So that is the equation of the tangent line at x equals 3. I want to find the derivative of this equation, y equals x times e to the 3x minus 2. To find the derivative of this, I'm going to use the product rule. So the first factor times the derivative of the second factor plus the second factor times the derivative of the first factor. The derivative of e to the 3x minus 2 will be e to the 3x minus 2 times the derivative of what's in the exponent. That's using the chain rule. And then e to the 3x minus 2, so this is a 2 up here, times the derivative of x will be 1. The derivative of 3x minus 2 is 3. And I can multiply that 3 and x together to get 3x e to the 3x minus 2 plus e to the 3x minus 2. And if you would like, you could factor out e to the 3x minus 2 and get 3x plus 1. So in this example, I want to find the derivative of y equals 1 over x minus 1, but I want to find the derivative not with the shortcuts, but with the limit definition. So the limit definition gives that the derivative of f of x is the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. So even though this says y equals, we're going to think of this as f of x equals 1 over x minus 1, and we'll follow this definition to calculate the derivative. So we want to do the limit as delta x approaches 0 of f of x plus delta x. So everywhere we see an x right here, we're going to change it to the x plus delta x. That's going to give me 1 over x plus delta x minus 1. Then I want to subtract f of x. So I want to subtract my whole function. So that's minus 1 over x minus 1. And this is all over delta x. So if I were to use direct substitution right now, you would end up getting 1 over x minus 1 minus 1 over x minus 1, and that would give you a 0 in the numerator, and substituting a 0 in for delta x would give you a 0 in the denominator. So what we're going to do instead is we're going to use the clearing fractions method to clear out these complex fractions that we have. So we're going to multiply by the common denominator, or the least common multiple, which is to multiply those two denominators together. So that's going to be x minus 1 times x plus delta x minus 1 on the top, and the same thing on the bottom. So in the denominator, I'm going to leave it in factored form because I'm hoping that something's going to cancel out. So I have delta x times x minus 1 times x plus delta x minus 1. And in the numerator, I'll distribute this to the first term. And when I distribute it to the first term, that fraction will cancel out, and the only thing I have left is 1 times x minus 1. And then when I distribute it to the second term, the x minus 1 will cancel with this factor, leaving me with 1 times x plus delta x minus 1. So minus 1 times x plus delta x minus 1. I'll use the distributive property in the numerator to give me x minus 1 minus x minus delta x plus 1 over delta x times x minus 1 times x plus delta x minus 1. And in the numerator, I have a positive x and a negative x, a minus 1 and a plus 1. So I'm left with the limit as delta x approaches 0 of negative delta x over delta x times x minus 1 times x plus delta x minus 1. And the thing that I was hoping for, that delta x would cancel, happened, and it cancels here. And I have the limit as delta x approaches 0 of negative 1 over x minus 1 times x plus delta x minus 1. And now I can use direct substitution. And when I use the direct substitution, I don't need to write the limit anymore. So I've got negative 1 over x minus 1, x plus 0 minus 1. That's negative 1 over x minus 1 times x minus 1. And that's the same thing as negative 1 over x minus 1 squared. So that is the derivative. And it is the same derivative that you would get if you used the shortcuts. So that's what's nice here. You can check with the shortcuts. So thinking about the shortcut, I would treat 1 over x minus 1 as x minus 1 to the negative 1. And calculating the derivative, I would use the chain rule with the power being on the outside. So I'd bring that power down. That power of negative 1 down, I'd leave the inside alone. I'd take 1 away from the power, and then I'd multiply by the derivative of the inside. And the derivative of the inside is 1. So that's negative 1 over x minus 1 squared.